Good afternoon. Welcome to my video on ShareHYDRO. ShareHYDRO is a simulation environment for use in engineering, hydrology, and hydraulics classes at Texas Tech University. And what I'm going to demonstrate in this video is a really rapid tour. This is a follow-up video from an earlier one showing the same resource, but I've made some significant modifications, and the resource is now to the point where it will be suitable for CE 5361 taught in the summer of 2020. So without further boring you, let's move forward. So what you see in the video is my desktop on my laptop, and it's a mess. So let's move that out of the way. I'm going to minimize this window, which is connected to a server. Just in case something breaks during the demo, I can restart it real fast. So here I have YouTube up on a browser, but we're going to go to the class website, which is www.rtfmps.com, and it loaded amazingly fast that instant because I actually already had this page in the cache. You can expect this entry page to take a little while to load, anywhere from 15 seconds to maybe as much as a minute. The server itself is quite fast. The network through which it works is sometimes not so fast. And the next thing is you've got to move your pet cat out of the way. No, don't. That mouse is for me, not you. The next would be, you could choose the ShareHYDRO up here in the tab or down here, or if you have less real estate than I have here, it renders with these 3 lines up in the right hand corner, and if you choose the 3 lines you can scroll down to ShareHYDRO. I'm going to go back to big use of real estate. And here's the entry page, and it has a little description on what this is. And then it has this video, which should be linked by the time after I make it. And there's a series of portals here, ShareHYDRO 1 through 5. They're identical. They each have a different password requirement to get to them, but the underlying installations are the same. So what's installed is Swim 5.1014, HECHMS 4.3, and PeakFQ 7.3. And the reason I've made several of these videos is getting that guy to run in the remote environment was difficult. It's a very clunky piece of software, and you actually see it when I demo it. Some of the workarounds to get it to run. And what you don't see here is HECRAS and EPANet. They're both installable, I think, but I didn't need them for this case. For anyone else that wants to do this, each of these portals has a configuration environment that's about 3 or 4 gigabytes just to configure all these to run, and that normally wouldn't be the case, but PeakFQ is such that I actually had to make duplicate copies of the wine prefixes in each portal rather than symbolically link to a single wine prefix that was pre-provisioned. And I'm not sure why that had to be so, but it's the currently working hack. So I'm going to demonstrate with ShareHYDRO 1 because it's got a little extra stuff, and it's got some files in it that we can demonstrate the different programs, and the other ones are kind of clean. So to go to the portal, you click on it, and you should be presented with a screen that looks like this. And this is says no VNC. So this is an open source project that is providing a virtual network computing tunnel, if you will, into our remote machine. And you can see the unusual URL formation up here. Now when we choose connect, a couple things can happen. if something fails, up at the top there'll be a red banner that says it means there was a failure in the connection. It actually gives some diagnostic. It'll either say server not accepting or server not available. That means something bad is wrong. If it says authentication failure, that often means you typed an incorrect password in. If you type the correct password a few times and it still doesn't work, then something deeper is ongoing. Resetting the whole service to get all the portals to restart isn't that hard, but I would need to know when you have trouble connecting what the failure mode is, because that will help me diagnose what's wrong. Okay, so we will now continue. There's no indication who we are. We happen to be Hydro 1. And so when we do the connection, I'm now going to type Hydro 1's password, which is, I sort of want to say it out loud, but I also don't know who's going to watch the video. And while there's not a whole lot of anything there to steal or damage they could do, I'd rather not give the keys to everybody. But people enrolled in the class, you'll be given passwords. They're not very elaborate passwords, and you can't change them. Actually, I take that back. You could change them if you knew how, but there's no ordinary password changing. So this is just a password to get to a desktop. It's not a password to the server. And this was a good connection. So it tells us we have an unsecured connection, and all that means is that data sent back and forth are not encrypted. Now, if you think of the data that's being sent, coming from the server to your screen is just pixels, and going from your keyboard and mouse back to the server are X and Y locations in the document object model, which is a fancy word for your window, your browser window, and the keystroke stream that as you prepare input. So while that would be pretty easy for somebody to intercept, it would be, I'm not challenging it, it would just be really a pain in the neck to do anything with it. So I would suggest y'all don't be too concerned with that. Obviously, don't put anything personally identifiable over this connection, and don't use this as a place to store important files, important to you. I mean, outside the context of the class. I mean, I'm not about to go steal class files. Okay, so here's what a fully provisioned desktop should look like. And what I want you to go through is, what you want to do is be sure it's laid out like this, because all of the lectures are designed as if this is what you're going to encounter. So there's a home directory. We'll look in that. It's currently it looks like the hidden files are turned on. I'm going to turn those off because they clutter things up. So there's what's in your home directory. Desktop downloads. I don't know why I have an R directory. We'll go take a look at I'll leave that alone. But there's this script right here called stvnc hydro1.sh. That's kind of important. So don't move it. Don't change its name. You can go look at it if you want to. I'll actually open it for you so you can see what's in it, possibly in our lifetime. So this is a script that's used to start and stop the virtual desktop. In other words, if you move or damage this script, you will lose access through the VNC connection. For anyone that's interested, I'll kind of describe what the script is doing. So it's run from somewhere else. It's actually run from the root account, and this and it's run under the command that says sudo-u hydro1. So this means super user, execute as a super user, make yourself the Hydro 1 user, execute the shell script in home Hydro 1 directory, and then this is the script we're looking at. And what this script does is it changes itself to its home directory. It issues a VNC server kill :2, so it attempts to kill the number 2 desktop, which if it's open it'll kill it. If it isn't, it sends a warning message that's trapped in the root account, and then restart the desktop. So Hydro 1 uses desktop number 2. So don't move or damage that script, or you're on your own. You're telling me, and I'll be cranky when I have to rebuild it. Obviously, the script isn't very hard, but I'd rather you not destroy it. And then there's a set of files here. Launch PeakFQ 7.3.bash, launch RStudio, launch Swim, launch HMS. And what these are short scripts that will actually launch the program. We'll go ahead and I'll let you see what's in one. I'd prefer you not to destroy these either, because you'll never, it'd take a while to rebuild them. So what this does is it launches an instance of PeakFQ. So it's going to run a program in user local bin wine, which is a shared build of the wine program, which is a compatibility layer to make it function as if it's a Windows machine. And then it's going to run that program. And it's going to run PeakFQ, but PeakFQ is located in home hydro1.wine. The .wine is called the wine prefix. Drive C, program files, x86, PeakFQ, bin, PeakFQ, Windows. So if this gets damaged, either if the .wine prefix gets damaged or the call gets damaged, the script just sort of sits there and doesn't do anything. And you have to run it from the terminal to diagnose what's wrong. But it's designed so that you can run it here from the desktop. So it should run with a double click, but I usually use the execute. So I right click the object, select execute, and then left clicked it. But let's try the double click, because that's what the world's used to. We'll know in a second. Okay, so there's a PeakFQ. We'll study this later in the class on what to use this for. But let's go ahead and just run it once so that you can see. This one is the most error prone of the shared programs. So I'm going to go ahead and open a file. And this is the hardest one to do because you actually have to know the file system structure. I'm going to this icon, which is the file system root. I want to go to home. I want to go to Hydro 1, desktop, PeakFQ files, and this one happens to have some files in it. So I'm going to go ahead and pick one out of here, see in pending, and I'm going to cherry pick one that I've already worked with a little bit. Hopefully it will save some time. I'm going for 863,000. Well, I think it's 0836,000. It's 083. There we go. So this directory 0836,000. Oh, that's not the right one. So that's the frustrating part of this shared environment. That's better. Okay, so this file 0836,000.pkf, that's an ASCII file that's formatted in the PeakFQ format. And we can go look at what's in the file before I actually open it. The lag that you are seeing me experience is a consequence of the network. And I'm pretty sure it's not the ability of the machine to keep up with me. Okay, there's a file, and all this other stuff is actually, if you look at it, I'm making this video on the 20th, and these files are just a couple hours old. So this was how I figured out how to work around the various errors that will come out in the program. So standard output is this empirical distribution. There's some exports, PNGs, portable network graphics. That's going to be a flood frequency curve. PRT is actually an ASCII file. It's a printout, and then there's a error and warning file. Forget what ECH is, and then there's a another text file. And these PDF files are not produced by the program. They are external. They are some ongoing research work. But the PKF file is actually all the input that it needs. And there is a contents of a PeakFQ file for the program. So it has this cryptic column over here, some header information here, and then you'll notice this looks like a date, year, month, day, a value, and another value. And when we study Bulletin 17B and C later in the class, we will learn what these different values mean. That's just an ASCII file. And you can see here's one which does not have a complete date, and it has this code B. Had the code B, but I moved it. And it has this code B. You'll encounter other codes other than B, but B is going to have something to do with a incomplete date. Okay, so now we'll go ahead and run the program. I've selected the file name. I choose open. I'll get an error message. And choose when you get this status monitor message, just choose no. If you choose yes, it's going to take you to a website. It's going to tell you you're an idiot and that you should download stuff, and if it doesn't work, insert your credit card in any slot in your computer, and Microsoft will fix everything for you, and they won't. So now we've loaded in, and let me go ahead and just run the program the way it would be for these data. Go ahead and use something called station skew. We're using expected moment analysis model. I'm going to leave my outlier test at multiple. I actually don't know what it's going to do. The multiple grubs spec test. I'm going to go to my input view, and it's going to render a picture of the data in possibly our lifetime. And we, as a user, have to I'm going to go ahead and select the I'm going to run it once like this. And when the EMA method can't handle these breaks in time, or it's not supposed to be able to. Then we go to output options, and I want to choose portable network graphics. I'll add an export file, I'll add a frequency file, and the path is already set, so it should put it back to the same folder where the data were contained. Okay, so now the reason I switched to these PNG outputs, the PNGs are relevant, but the reason I selected items now is if you attempt to resize it, it breaks the program and it'll just hang on you. You'll be able to actually exit it, which is pretty unusual for a broken program, but it will just it'll just hang on you. We're going to run it from the input view. And I'll go ahead and hit the run, and we'll find out if it's going to work or give me an error message. I think I'm going to get an error message. There we go. This error message is telling you that it can't run the EMA analysis. You can either go back to Bulletin 17B and run it, or you can provide the inputs. We're going to go to 17B because I'm just demonstrating the working environment. Get the status monitor failure. Let's go ahead and view. And it's produced a output graph. I'm going to attempt to resize it. This may actually break things. But I think when you produce the portable network graphic, you don't get this clobbering here of graphic elements. Everything is readable. We'll go check that in a second. But it tells us the analysis. The teal colored dots are the observations converted into their Weibull plotting positions and then rendered in increasing order. The open circles are low outlier identified points, and they are removed from the analysis. So this red curve, which is passed through the teal points, does not include these 2 points. And then the 5%, 95% confidence limit is plotted on this plot. So that's what the PeakFQ program does. And we're going to use it later in the semester. So when we're done, we can go ahead and exit that. And the output's already been saved. Since I don't trust it, I'm going to save the specifications, and I'm going to PSF. Okay. I chose no because I actually don't want to clobber the existing one there. And we choose exit. We exit the program. So that's how to run PeakFQ when we get to it. The remainders are going to be a little bit easier. There's a RStudio launcher, and I've clicked on the launch RStudio.bash file, and as usual nothing's happening because I'm capturing it on video. And as Tom Petty says, the waiting is the hardest part. So there's RStudio loading in the background, and there is Firefox refusing to accept input, which is pretty typical. And I think this is an example from one of the other lessons. So we can go ahead and run the example, and it looks like it produced, we did these calculations. It wasn't programmed to do any output, but if we type runoff, we can see the contents of this object named runoff. It's 0.139, and that's a different video to explain what that means. But that's RStudio, so it's installed. Let's cancel the exit. Let's see if there's any other R files around. Hopefully let us browse the file system. It will. In desktop, R scripts, my R scripts. So here's quite a few. We can let's go to lesson 12. I think that's unit hydrographs. I'm just going to pick one. So we'll go ahead and open that file. Hopefully it got the input. There's the hydrograph file. Let's go ahead and switch directories to the source file. So it's now in the correct directory because it's going to need to read a file called pq.txt. Go ahead and run the program. This one I think produces graphs. Can't read the graphs because I have, there we go. And so this is some part later in the class of plotting unit graphs, and if we want to be fancy, we can change the plot type from stair step to line. So the line plot's going to look like much more triangle-y. And it's a matter of opinion on which is better. It depends on how well your brain can interpret what it's seeing. The other type would be points. I'm not sure that's even going to be viewable, but let's give her a try. Basically, we're verifying that the R scripting environment's working. Source it. And yeah, the points are almost incomprehensible. So we'll put it back to stair step, which is the one I can comprehend. All right, excellent. So RStudio exists, at least in Hydro 1 is running. Just go ahead and save it for the time being. The next program we're going to check is launch HMS. Now this time I launched it by choosing execute. So I selected the file, right-clicked, chose execute, and HMS takes a while to launch at its first launch. It's usually faster if you've been using it a while. So we will wait on it to do its thing and load. And if the entire plant weren't all watching cat videos, streaming them to their home computers, I'd have faster internet. And this would appear to happen faster. And so undoubtedly at the remote end, the window's already rendered. It just hasn't established the communication back to this window yet. Make sure it's actually the right script, because that sometimes happens. That's the correct script. There we go. So I don't think my messing around had anything to do with this arriving finally. It was going out trying to figure out how to think. So I'm not sure you'll be forced to have to agree with this every time you load it, but you just want to agree to the above terms. So what you're agreeing to is, I'm using a federal government program, and by choosing to use it, anything that's crappy is my fault, not yours. And sometimes you gotta do it like you're from the valley, for sure, for sure. Now we want to wait for the software to load. And ta-da, there's HEC-HMS, and it's, oh, I've got 2 instances. Well, I didn't even know it could handle that. That's kind of cool. We'll leave both of them up for the time being. Let me see if I have any files saved here. So, home, header 1, desktop, HMS, my HMS, Hardin Creek. Okay, cool. There's one here. And we want to find my life model.hms. That should be the meta file that will load everything in. Hit select. And there we go. Let's resize it before we try anything and see if I can't break the machine. Okay, this particular model is comprised, looks like, of several objects. Let's see if I can figure out how to view out. So I've got the mouse pointer in the drawing canvas, and I'm going to use the wheel to try to zoom out, and that's kind of what I want. So we have a area here called west, goes into a reservoir, goes into a conduit to a junction. Area here called north, so this is the sub-basin, goes into a reservoir, goes into a channel to a junction, and then there's this Eden one that goes into a reservoir, and I actually don't know which way it flows in this channel, if it flows from 87 to junction number 1. We can check that, I believe, if you select an object. So it's flowing from the junction to the US 87 reservoir. Okay, and we'll study more how to do that later in the class. Let's go ahead and attempt to run the program. So we go into the Compute tab, select run number 1. So this has already been pre-programmed. I mean, even someone working at a fast food restaurant could operate this program at this point. And it should be done. So it claims the run is completed. As I recall, there were some warnings. Okay, those are actual warnings about computation, and those are documented later in the class. Let's go look at the output. We'll go look at US87 and let it plot a graph of some hydrologic variables. So it's got the pool elevation, the amount of storage, the outflow, and the combined inflow, which is this dashed line. And so I would say that that's HEC-HMS running, which is the point of this video. Let's go ahead and exit. And the last thing I want to demo was swim. Let's run that by executing the script. Wait for it. And here's a swim window. Like everything else on the remote, it doesn't want to accept input. And we'll go ahead and just load and run a file that's already there. Should be one called LazyBrook, and must have the wrong, get out of the wine prefix into the desktop, EPA swim, Hydro 1 projects, LazyBrook. I'll open it. A model there. Let's go ahead and this happens to have a backdrop associated with it. There's our program. We run it with the lightning bolt. And we'll look at this last conduit. We'll just see what the flow in it is. And so there's the flow for the system. And when we get later on in the class, we'll explore how to actually use this. But so we've now verified that the tools work. And this is a change from the prior video because I've added the PeakFQ portion. So thank you very much for your attention, and look forward to you using these tools in the class. The faster internet you have, the more effective this will be. The lag time is going to drive you crazy, probably. But this is to save you from having to download and install the software yourself, which for PC people is not horrible, but the Macintosh builds are, well, I make them myself. They're clunky at best, and they need to be redone because Catalina pretty much bricked everything. So if you're running a Macintosh, this is an option for you. We will discuss how to move files to and from these computation environments. I've elected not to have obvious uploaders and downloaders, and I'll show you a way in another lesson. And that's mostly so that you think about what you're doing. And I'm lazy. So thank you for your attention. I'm going to stop the recording